So I believe you are developers, even junior developers, you know about continuous integration. And continuous integration in Java basically means we compile, we test units, we package, we test the integration of everything. Sometimes, I mean, if you are like really hype, you create your containers, you store it in. I believe that everybody does it. Everybody does it up to a point, but everybody does it. And I have like realized there was this trend since a couple of years that you say CI/CD, that like it's a compound word, and it is faceless. You don't understand what it means really, but it's CI/CD, meaning you have got a pipeline of something. And while continuous integration is, again, I believe it should be the norm, it should be the standard. If you don't have it, then probably something is wrong with the organization you are working in. Just leave right now. The CD part is much harder. Like continuous, first thing first, CD means nothing, because CD can means either continuous delivery or continuous deployment. And again, continuous integration, quite easy. Continuous delivery means that you make the package and it's ready for deployment, and you need to have one manual action. In general, is the decision business saying, hey, yeah, you can deploy it. And then you've got continuous deployment and everything is automated. So basically you just git push and you've got your whole pipeline of integration and delivery and deployment, and it's deployed in production and you've got something in production. This is really very hard to do. I think the return over investments, if you are not Google, if you are not Facebook, if you are not one of those big companies, is quite low. And if you do continuous deployments, basically you have one big issue. In general, you don't have to have any downtime. Like, did you ever have Facebook or Google search tell you, hey, sorry, we come back in a few minutes. We are now deploying. I mean, they are Amazon as well. So if you are deploying all the time and every time you need to have a static wait page in front of your app, it doesn't work that well. So if you are a Java developer or a Kotlin developer or Scala developer or whatever, like if you are working on the JVM, generally when you want to deploy something, you need to stop the JVM first. It can be a self-executable jar. You need to stop the JVM, you deploy the new jar, you start the JVM with the new jar, or it can be like a regular application server or servlet container. You need to like stop your service in all cases to deploy this new war. And so you have downtime, and downtime is not really good. But we solved downtime problem a long time ago. You might tell me, we have blue-green deployments, and you have these old books saying, hey, like blue-green deployment is very easy. You have these green environments, which now is your production environments, and you have everything on it. And then meanwhile, you deploy on the blue environments and nobody is there. And then at some point you just switch a button and then the router routes you from the green to the blue one, and the blue one becomes your new production environment and there is no downtime. Well, yes and no, because I mean, switching a button and routing all your user from the green environment to your blue environment is not instant. Probably there is some lag. You might have issues about the state as well. Like, hey, like how do you copy all your data from the old database to the new database instantly? Doesn't work that well. So you will answer me, hey, but come on. I mean, you have a single database. Yeah, but then how do you handle like database schema changes? So it's a kind of worm. And then you have, how do you handle the sessions? Because now, how do you handle the users who were previously on the green environment and you move them to the blue environments? I mean, there is states. There is not only state on the database, there is state on the app server. So you need also to copy the state. And to do that instantly with like a lot of users, like a huge mess of data, is not easy. Come on, we have Kubernetes. Kubernetes solves all the problems in the world. You know, you have this rolling update. So basically you deploy your version 1 on every node, and then, sorry, on every pod. And then you say, oh, I will just do a rolling deployment, and you change like pod by pod. You change the version, you upgrade the version. But likewise, it doesn't solve any problem of the database or the session. It's just a commodity, but it's not great. So how do we handle this like Java deployment, bytecode deployment? Well, we have a magic solution. We can change the bytecode inside of the JVM with no downtime. So that's what I will try to tell you in this talk. We need to see through a couple of steps. The first one is the Instrumentation API. The second one is the attach API. Now, afterwards, we will do the streaming part, and I will try to have this demo. So the first, the Instrumentation API. You might have probably encountered during your career Java agents. Even if you never developed Java agents, you might be familiar with the term. So what is the Java agent? A Java agent is just a specific jar. So it's just a simple jar, but with specific metadata that tells, hey, it's an agent. And an agent is part of this like Instrumentation API. And this Instrumentation API is the API that allows you to change the bytecode of running application. There are two types of agents. In general, people are familiar with the first one, the static one, like the one you set as startup, java-jar-java agent and pass to my jar. That's in general, when you have monitoring on the JVM, that's what you do. So you set that Java agent when you start the JVM, and presto, some magic happens. Probably you have metrics that taken from GMX or whatever. But there is another kind of Java agents that people know less about. It's a dynamic Java agent. So you start your JVM, you start a single JVM, and then you start another JVM that will like attach this agent to the first running JVM. To configure an agent, it's quite easy. The first, you must have an entry point, just like in the regular Java application, you must have a main method. In a Java agent, you must have either a pre-main for a static agent or an agent main for a dynamic agent. And likewise, it needs to be referenced in the manifest. So just like you have a pre-main method, you have a pre-main class entry. And when you have an agent main, you have an agent class entry. Again, this is very similar. So when you have your main or your main class in a regular jar. Notice that there is an additional parameter, instrumentation. I will talk a bit about it just afterwards. So instrumentation allows two things. The first one that we will use in this demo is to change an existing class implementation. And there are limitations. You can't do everything you would like to. Or otherwise, when you start to load bytecode, then you can apply an automatic transformation. This is the Instrumentation API from a bird's eye view, but the final API is not much more complicated. So basically, you've got this instrumentation that is passed in the agent main or the pre-main method by the JVM when it gets invoked. And actually the one that allows you, the method that allows you to redefine running bytecode is this one, redefine classes. And it allows to pass a var arg of class definition. Class definition is what? It's just a normal class and bytecode. This byte array is just bytecode. So once you are able to create this class definition, you can pass it to redefine classes, and then the JVM will reload the class and change the runtime codes. Again, you can also have like class file transformer. It allows you to do automatic transformation of newly loaded bytecode, but we won't use it into this demo. As I mentioned, two types of agents. The first one static, the second one is dynamic, and the dynamic agent is part of the attach API. The attach API allows you to load an agent inside another running JVM. And very important, you don't need to run this first JVM in debug mode. So you run a standard JVM, it knows nothing about the world outside. You launch another JVM, it will take the jar and put like the bytecode of the jar inside the first JVM. There are only two requirements. They need to run on the same system. So I didn't find any way to do that remotely. And you must access the PID of the first JVM. The API is even simpler than the instrumentation API. You've got like this abstract class, and of course you've got an implementation depending on your exact JVM. Basically, you've got this static method. You pass the ID of the PID. It returns you a virtual machine, and then you load the agent and you pass the path to the jar. You can also add options if you want, but in general, it's like quite easy. So with the instrumentation API, we know how to change running bytecodes. With the attach API, we know how to take an agent and attach it dynamically to a running JVM. What we need now is a way to read some classes, some bytecode, and stream it to have continuous deployment. So we have two ways to do that. We could do that in batches, or we could do that in streams. The thing with batches, well, at some point we stop. We say, oh, take this data, move it, when it's done, it's finished. Here, we can have as many compilation events as necessary, as long as we are working. And so in that case, we have an infinite streams of events, or I would say potentially infinite streams of events. So that would be akin to streaming. You might have heard about some in-memory stream processing engines. You can use them in the cloud. So for example, you have Kinesis for Amazon or PubSub for Google. There are also a couple on-premise. You might have heard about Flink, Jet. I need to mention Beam because I think it's a great initiative. So basically Beam tries to be an abstraction layer over other either cloud or on-premise stream processing engine. So you don't need to worry yourself about the implementation details. You just need to call the API. It's super leaky, of course, because there is no standard regarding stream processing engines. Every engine has its own quirks. It might have different semantics. Still, I think it's a good initiative, so I mentioned it for that. So Jet is an Apache 2 open source license in-memory stream processing engine. It consists of a single jar, and it has an API which unifies batch and streaming. So you might start with batch because you might be more familiar with batch. Then with a single change of line of code in your data pipeline, you move it to a streaming API. There are two ways to deploy Jet or to deploy Hazelcast, because Hazelcast Jet is built on IMDG. You can use it, the easiest way to start with is you use it as a dependency inside your application. And in that case, like when you deploy your application, it will be a node. So basically your application and the Jet nodes will form one, and then the Jet nodes will form a cluster among them. That's very easy to start with. However, you need to scale your application and your Jet cluster. Like the scaling is dependent, it's coupled. In general, you want to scale them independently. Perhaps you need more like computing power, so you need to scale horizontally much more your Jet cluster than your application. So for that, we have another deployment model, client server. Of course, in that case, there is more network traffic, but the advantage is we have different clients in different languages. So in that case, you don't need to do Java development. You can have your Jet cluster running, and then you can have like a Node.js client or a Python client or a Go client. Well, we have a couple of clients. We like a Jet pipeline as well. In general, this is a stream processing pipeline, but read from some sources and writes in some sinks. Here you can see by default what we can read from. We can read from Kafka, we can read from a file system, we can read from database events by leveraging the Debezium. And if nothing fits you, of course, you can write your custom collector. We can also read from IMDG, of course. The things are likewise, you can like write in a database, write in the file system. And again, if nothing fits you, you can write your own. And in between, you can have everything that you need to like manage your data. The benefit of using Hazelcast Jet and Hazelcast MDG is if you need to enrich your data by like with static data, you can first like put that data inside of IMDG, so also in memory, and then compose them, enrich them directly in memory. And instead of every time having to read the database, which is not great. Of course, you've got aggregation if you don't need the raw data, but you need aggregate events, you can do that. And as I mentioned, is distributed all over the network. So basically, Jet is also a stream processing computing engine. It's able to know which nodes it can run its computation on and send the computation to the correct node. And just as Java 8 streams that run on a single node, you have all the good stuff, just like filters, maps, whatever. Now, this is my final architecture. We have all the pieces we need. So imagine we have a production JVM that runs an app. So it's completely decoupled from everything. Now we will like compile our source codes, and we want it to be delivered to the app. So we will create a Jet job that will read this file system and read the bytecodes. And when there is a change, it will stream the changes to IMDG. So we will store the results in a map or in memory. And meanwhile, we have another JVM, and we have compiled a jar that is able to read the data from IMDG and change the running bytecode. So this is set in a jar, and we run this injection JVM. It will like take the jar, read the jar, and attach the jar to the app. And now the app becomes able to read the data from IMDG, and when there is a change, it will reload the bytecodes. From a sequence point of view, it works like that. So we will start the Jet job, and the Jet job just loops over and over the source class. If there is a change, it will set the bytecode in the IMAP. The agent will attach the jar that has been pre-compiled into the running JVM. And now the JVM will subscribe to changes from IMDG. And every time there is a change, then it will reload its bytecode. Time for a demo. So here, I have all those projects. And if at any time you've got questions, please don't be shy, just ask me. I will close everything and I will go through all of them. So here I have a simple project that runs a stupid servlet that says, hello world. I will run that and it will be my production JVM. And as you can see, I run it like I don't run it in debug. And compared to what I told you, it didn't work this morning with like dynamic agents. So I'm doing it with a static agent. So I'm running it like this. For whatever reason, it doesn't work with dynamic agents today. I don't know why. So I need to be a bit faster. The second stuff that I did is to create these agents. This is already compiled. What I do in this case is, again, because the dynamic stuff doesn't work, I've created a pre-main. So basically this agent can work as a static agent, but also as a dynamic agent right now. And what I do is it will be a client to the Jet job, and it will add this bytecode change listener. So when I have a change in the IMAP where I store the bytecode changes, then I will do a class 4 name, and I will use these instrumentation redefined classes that I have told you about in the presentation. This is just a place where I will do my changes. So you see that I have this hello servlet as well, but here it will be the deployed one, which is in work. And this one is where I will make the changes. So this is basically what I will compile, and the Jet job will read the changes from the file system. Then I have the job itself. And the job itself will read from the classes, and basically here, ingestion timestamp, when you do stream processing, basically you need to have timestamp, to have ordering and whatever. And it's the difference between a batch and the stream processing. The filter using service will check first if there has been changes with the existing bytecodes, because there is no need to reload the class if the bytecode hasn't been changed. So if it has not been changed, I do nothing. If it has been changed, then I put it I transform it into a IMAP entry, and then I write it into the map. And finally, the attach stuff that here won't be used, unfortunately, is, as I mentioned, very stupid. First, you attach to a PID, and then you load the agents. And because I'm super lazy and I didn't want to check the PID, I've created a method to directly get the PID. As you can see, it's written in Kotlin. So whatever JVM language you write it in, it's not important. Yeah, I love Kotlin, sorry. So now I will be starting my servlets, and I will be creating the Jet job as well. And now the Jet job has started. It has started an IMDG instance in between, and my servlet was able to connect to it. And I don't have Firefox. Where is my Firefox? Firefox is not here. So I need to start Okay, I need to start a new window. And I need to localhost 8080. And I need to do it with hello. So here it's my running production. And now I will just change the source, the one that is not used. Remember, this one is used. This one is just completely not used. This is this one. I just double check it's the right one. Yes. And now I will say, hello, Bangalore. I just compile it. Now it would be good if it worked, because again, if my demo doesn't work for the second time, it will be bad. Now it seems it's bad. The Jet job doesn't work. Congrats, everything is done. So I will restart from scratch. Here I say hello world, I recompile. That's the fun of demos. I start here, I run it, I start the Jet job. It should connect to the cluster. Okay, it seems I have a big issue, so let me compile everything. Source. Okay, I have the Jet job running. I run the servlet. It's connected. I just check that. Now I have it. Hello. No, I don't have hello here, so I will write hello. Too fast. Yes. And now I write Bangalore and I compile, and please let it work. Yes, finally.
Yes.
Yeah, sorry.
Congrats.
Yeah. Well,
it's a bit like the commentator's curse.
So finally, I've got my results, and the good thing is that my servlet is still running the old hello servlet that says hello world. But now, at runtime, it has been transformed by the running JVM. And yeah. So of course, it's not perfect. Again, the dynamic stuff doesn't work. I don't know why. Here, if you are used to have to deliver jars with versions, you have no version tagging. Also, the instrumentation allows you to load new classes, but here I didn't do it, so the demo doesn't do it. Instrumentation has some limitations also. The redefine classes method that I'm using cannot add or remove or rename fields or methods or change the signature, whatever. So basically it's good if you change the body of a method, but not more. However, we can do some improvements. Like here, I'm using everything on my own machine, which is not very great because yeah, you just trust me that I'm not cheating. Also, the GitHub repository is available if you want to change it. But in general, what you would do is you would have a CI pipeline and you won't read from the developer machine. You would read from the folder that is the result of the CI pipeline. If you want to have like tagging, you could add additional metadata in each class. For example, you can also get the Git tag and like wave it into the bytecode using a class transformer if you want. And also here, every time I do some changes, I need to, I might need to restart the class loader. So if you have dedicated class loader, if you have like Spring DevTools, you could like reload the class loader without reloading the entire JVM. So there are some improvements. It's just like fun stuff. As I mentioned, you can read more. I mean, if you want the repo, you just go to bit.ly /bytecode streaming. And of course, you can read my blog of